In this example, we are going to go over k-means cluster analysis technique. So if you remember, we talked about k-means cluster. It's not the same as the hierarchical clustering method. In this case, we divide the sample into k non-overlapping clusters, and each of the k clusters should be as homogeneous as possible. And as we said, the k needs to be specified before performing the analysis. So in this example, we have countries' information technology use has been linked to economic and societal development. A nonprofit organization collects data that measure the use and impact of information technology in over 100 countries annually. The data contains variables: country number, which is the country, hardware industry, software industry, telecommunication industry, and individual usage, business usage, government usage, diffusion of e-business, and diffusion of e-payment. And each value in the table represents the score that a country has achieved for a given category. So the range of the score is from 1, lowest, to 7. So we have scores. We have scores for each category. We have scores. We have many variables, as you can see. And we have scores. So the questions that we have here, we would like to perform k-means clustering to group the countries into 3 clusters. So it's specified in advance, 3 clusters of the following variables. So we have to use these variables only for clustering: individual usage, business usage, and the government usage. These are the ones that we're going to use for clustering. And the question says, is data standardization necessary in this data? So to answer this part quickly, the answer is no, because we have the same unit. It's a scale free, right? So we do not have different units. We have the same unit or the same score, the same range from 1 to 7. So from 1 to 7. So there is no need to data standardization. What are the size and the cluster center values of the largest cluster? Which cluster has the highest average diffusion of e-business? Which cluster has the highest average diffusion of e-payment? Then part C, we have to again use k-means clustering to group the countries using all variables except the country number, because the country number is just the ID number, right? So we have to repeat like the part 1, but we have to include all of the variables when creating the clusters, okay? So the question says, what are the size and the cluster center values of the largest cluster? So this is a straightforward question. So let's first do the following. Let me clean this. And let me clean this. So let's run the code. So I just have the library cluster and the reading, how to read the file. This is my file. And I just want to look at the summary, because I would like just to make sure that the range is really as claimed by the question. It's from 1 to 7. And as you can see, minimum, maximum, yes. Or from 0 to 7 even. So, because we have here 0.9, so it says from 1 to 7, so is it 1 to 7? Yes, lowest. So, do you want to exclude this one? There is no need, I guess. You can just keep it. But if really we have scores from 1 to 7, we need to clean this data, or we change it to 1, like the minimum value. After that, we are going to work together in getting the same data. So, let's set the seed as 1. k-means results, so let's call it k-results. I'm going to use a function called PAM. There are many ways of doing this, by the way. There's not the only library. So my data, we're going to choose a specific variable. So let me look at my data first. These are the variables, and we are going to focus on which ones? Individual use, IU, BU, GU. Okay, so let me go there. IU, BU, GU. This is 1, 2, 3, 4, 5, 6, 7. So 5, 6, 7. Let me choose 5, 6, 7. And I'm going to have another argument. So the PAM function contains at least 2 arguments. So k equals 3. Then we are going to look at the summary that tells you everything about this clustering. Okay, so what do we have here? We have, first of all, we have the medoids. The medoids, we have, first of all, we have 3 clusters. Cluster 1, 2, 3. These are the representatives of each clusters, the IDs. So the observation 114, observation 124 is the representative of the second cluster. The observation 41 is the representative of the third cluster. And these are the values that we found for this observation. This observation has these values for the individual use, business use, etc. And these are not any observations, by the way. These are the medoids, okay? And the medoids, they're almost in the center of each cluster, the medoids. So they're almost the center of the each cluster. And the clustering vector is we have how many observations? We have 139, and this is the classification. So the first one's going to go to cluster 1, the second observation is going to go to cluster 2, and so on. And this is optimization problem. So the goal is to minimize the distance. So these numbers, we're looking for these numbers to be the minimum bit. And some information about each cluster. So if you look at the first cluster, tells you the size of the cluster. How many observations do you have in the first cluster? How many observations in the second cluster? How many observations in the third cluster? Also, we have the dissimilarities numbers. I mean, the distances. Dissimilarity means distances. So this is the maximum distance between any two observations, or the farthest, let's say, two observation in this cluster. This is the maximum distance. This is the maximum distance. You can look at, I mean, it's clearly that you can see that this cluster could be the more coherent cluster, because look at the distance is the shortest, right? And this is the average distances. And this is the diameter of the cluster, because it takes a shape, right? So it seems that, again, this cluster is the smallest. And maybe, again, because we have 34, observations only, because the others we have 58, let's say. And this is the separation number. What else would like to know? Yeah, do we have isolated clusters? No. The isolated cluster is the one that's out of the structure, which is we have no problem with. Silhouette plot information is very nice, plot. For example, this cluster 1, this observation belongs to cluster 1. And the nearest cluster to this observation is a cluster 3. And what is the silhouette width? The silhouette width tells you exactly how similar the data point is to its own cluster compared to other clusters. So we're looking for this number. Okay, this number is between -1 and 1, by the way. So if we are closer to 1, again, what does this number represent? Is the measure of how similar the data or the data point is to its own cluster compared to the other clusters, compared to the nearest cluster, let's say this one. So closer the value to 1 means that this point is well clustered and distant from the neighboring cluster, which is 3. So we have good clustering in this case, because this is closer than, this is close to 1. But if you have a 0, close to 0, that means the point, it's by the decision boundaries of the two clusters. It's like in the boundaries between the two clusters. But if the number is negative and it's close to -1, that means we have a point that is classified wrong. It belongs to the wrong cluster. Okay, it's kind of assigned to the wrong cluster, especially if it's close to the -1. So these are the silhouette width, and we can see a graph or plot for this one. Let's look at the plot. Before we go to plot, we have the average silhouette width per cluster. So this gives you the average calculated separately for each cluster. So for each cluster, this is 0.38. The second cluster, 0.52, 0.54. The higher the average, it means we have a better separation between the two clusters. So a better separation means what? Means we have a coherent clusters. So it seems that, as we said before, remember, cluster 3 is the one that we have really a coherent, the most coherent cluster, okay? This is the overall coherent, the overall clustering or silhouette width, which is, the overall average silhouette width across the data, which is the quality of the quality of the clustering for the entire data set, which is 0.5 almost, which is good. So let's put all of these in data, like in a table, and aggregate this. Let's add that clustering or the cluster numbers to the data set, then we aggregate the data as we did before. So I'm going to put the my data, and I will add a clustering column to the my data. So I'm going to say my data. I'm going to keep it I'm going to keep the same. I'm going to call it my data 0. So data frame, I'm going to add my data. Also, I'm giving k result. K result gives you, it's a list. We have so many things. So if you add a dollar sign, you're going to have many things. Medoids, ID mid, the clustering. So we're going to look at the clustering only. The clustering is the column that we're going to add, is a vector that we're going to add to my data. Okay. So if you run this my data 0, it becomes 10 variables. So click on this. So we add the cluster for each of the variable, for each of the observations, sorry. So let's aggregate these based on the cluster that they belong. So the question says, give me the max. So we're going to find the maximum number. So the question says, for B, which cluster has the highest average? Which one asks the highest average? So we're talking about, of e-business. So we are talking about the highest average diffusion of e-business. So we're talking about the averages here. Why I thought that we have a max here? Where is it? Did you see a maximum? It's all about average here. Means, okay, this one is the largest cluster. So the first one is the average. The second one is the, no. What are the size and the cluster center values for the largest cluster? No, this is something else. What are the size and the cluster center values of the largest cluster? Okay, which cluster has the highest average diffusion of e-business? Okay, to answer the second part, okay, the first part, we're done with it. What are the size and the cluster center values of the largest cluster? Okay, the answer is this. The size is 58, 47, 34 is the size. And the center values of the largest cluster are these medoids. These are the center points. For each, the first cluster, we have this center point. For the second cluster, we have this center point. For the third cluster, we have this center point. Medoids, okay, we have different meanings between medoids and centroids. The centroids is the average calculated, but the medoid is the observation. So I think the question is asking about the medoid. He is not asking about the cluster center values. It doesn't ask about the centroids. So we will be just talking about or taking the medoids in this case, or we can find the centroid if that is required. But the size of the largest cluster, the largest cluster, as we said, is the cluster number 1. And what is the middle numbers or the centers of the largest clusters? These are the centers. Where is it? This is the centers, which is this observation. These are the center values of I, U, B, U, G, U. Okay. Then we are going to which cluster has the highest average diffusion, right? So we would like to complete and do the aggregate function to create the table. So let's continue here. So we're going to find the average aggregate. And based on what? Based on my data 0. Based on this column, which is called k-result.clustering. K-result.clustering. And my data is just my data. You can say my data or my data. But I would like to take off my data 0. I'm going to take off what? The first column, because we have the ID. And what the function I'm going to use? I'm going to use the average, mean, right? I'm going to get the mean. So after getting the aggregate, let me see the aggregate function. So this is the aggregate function. We have the first clustering. I would like to add the number of the clusters to this. So the number of each, okay, cluster number 1, 2, 3. Then I would like to add the count. So let me add the count. So what is the count each cluster? We can get this by the table, right? Table, then count the cluster, easy. My data 0 and k result dot clustering my data. Let me check this. So this should give me the table. Okay, so this is the count of each cluster. Then I'm going to add this to this table. Okay, I'm going to add the numbers. 58 for the first cluster, 47, 34. And we can add this easily by average clusters. We have average clusters. I'm going to add the count, let's say, which is this guy. If you don't want to do this step, you can immediately just throw this one here. I mean, it's straightforward. So you have the average clusters now. Now, if you check the average clusters, let's check the average clusters. This is the average clusters. So these are the averages for each cluster. So you said the largest one is the first cluster, right? And the size of the largest cluster. But the question says here, what do we need to get? Which cluster has the highest average diffusion of e-business? Diffusion of e-business, which is EB. Which one has the highest average of EB? Okay, let's go down. Let me hide this. EB. Which one has the highest average EB? So we are talking about the highest average. We're talking about the third cluster, right? The third cluster. Yes, the third cluster. Because we got the mean, so there's the one that has the highest EB is the third cluster. Then we are going to go back. So the question doesn't say plot, but I'm going to plot this because I would like you to see the silhouette chart and to see the separation between the three clusters. So let's do the plotting, okay? And it's not complicated, just plot. Okay, result, easy. Not deploy, plot. Okay. So we got two charts. One of them, because we have three variables, we cannot put them in 2 dimensions. So we use the PCA here, PCA. So first component, second components, and they explain about 92% of the variabilities. Look at the clusters. These are kind of the clusters, 3 clusters. Look at the separation, by the way. The separation, do you remember the cluster 3, which is this one, is the best in terms of the separation? And look at cluster 1 and 2. There's an overlap, right? And let's look at the silhouette numbers. So this is cluster 1, 2, 3. Look at the 3. It has the highest silhouette width, 54%. Although we have one observation, look, it has a negative value. It's kind of belongs somewhere. Look at maybe this one. Where is it? Maybe this one. Or yeah, maybe this one here, or something in the boundary or whatever. So these are the observations and the silhouette width for each, and this is the average for each cluster of the silhouette width. So the goal is to get higher numbers. So all of the observations, they have to have to go closer to 1, right? But the third cluster means we have the highest numbers. So it's the most coherent cluster, as we said. Number 1 is the least coherent one. Look at these observations. Some of them, they belong to other clusters. Look at them. They're inside this clusters, like here, maybe. Yeah. So this is the silhouette plot. So the goal is to get most of these guys here, but still it's above the average. The average is 47%, which is somewhere here. So which is perfect for the cluster 3. Cluster 2 and 2 is good as well. 1 is not that good as 2 and 3, but this is fine. So this is the first part of the second part. We're going to repeat exactly what we did, but for all variables. So the cluster is going to be based on the whole data set, okay? So I'm going to copy this and paste this one here. Actually, I'm going to paste everything and copy this one, but I'm going to be very careful, remember. Now I'm going to do this, but the data for everything except the first observation. Okay, so I'm going to take the first, not the first observation, the first column, the first variable. I'm going to call it k-result 0 or 1. Okay, k-result 1. So we have two problems. Also here, I'm going to create my data 1. Then I'm going to use my data, etc. Then my data 1. Then I'm going to, this is my data 1. Carefully change all of these, but I'm going to change the function if necessary. So let me first, and this is a plot again, k-result 1. Let me check before running. Let me check the question again. The question says, use k-means clustering into groups. The country is using all the variable except the country number. Fine. What are the size and the cluster center values of the largest cluster? And the question does not ask me to do anything else. Even there is no need to do the aggregate function. But let's do it. So this is enough for us. So the size of the largest cluster is cluster number 1, which is 63, right? And what are the values of the center of this cluster? Are these the values? 4.4, SW 5.4, then 5.1, then 4.2. Okay. Again, I'm using the midpoints here. I'm not using the centers like the averages. Okay. Can we do the averages? Yes, we can. But I'm going to use the midpoints, which is okay. So we just answered the question. So it's just enough. We have to write this down, right? But let's continue and find the mean or the averages for these guys. And we can, as I said before, we can still look at the numbers here. Where is that? We can still look at the separation and max. This is nice table, by the way. You can look at the max dissimilarity measures, the average dissimilarity measures, the diameter, the separation. Look at the separations. And also we can look at the plot. So again, we have, the first clustering technique we did using 3 variables was much better than this one because the silhouette width were higher for all of them, right? Look at the average 0.4, but still we are above the average, which makes sense. Also, the separation is good because we don't have as many negatives as the previous one, but overall the separation is not stronger than the previous one. And we can see this from this guy. Look at this. They're all like, there is an overlap among the 3 of them, right? And the data sets are kind of spread more than before. And if you compare the distances or the dissimilarities, they're higher than the previous ones, right? But anyway, we are using this one as we are just answering the questions and the separation here based on all of the variables, okay? Yeah, so this is the way that we do the clustering or the k-means clustering, okay? And it's good to write a conclusion or just describing what you have seen in terms of the distances, the dissimilarity measures, the averages, the highest cluster, the size of the clusters, and so on. So these are important things that we have said actually, and the silhouette width and the silhouette width per cluster, and just if you write a description about what you have seen, this will be really important in kind of describing your analysis, okay?